Welcome to the Winglang update. Name to be decided. Forget everything you know about programming language for the cloud. Now, welcome your host, Eyal Keren.
Hello, and welcome to the Winglang show. I'm excited to have you here. Hope you are here. I'm not really sure. This is a new setup, and we have a very interesting show with us today. We have it's going to be co-starred by Elad. Will be joining us in a second. New format exactly, and we're going to talk about snake case and camel case. We're going to talk with Romain about JSII, the special guest that we have here today. We're going to show a little bit of the new test statement that we've introduced and talk about the cloud service, the cloud website, sneak peek about the resource compatibility metrics, and then our new kind of an introduction to our new learn.winglang.io experience. So we got Marcio. So without any further ado, I'm gonna have Elad join us on stream. Let's see that it works. Elad,
hey man, what's up?
How you doing, man?
What's going on here? This is kind of weird.
It's kind of weird, but we have kind of all the important people here, as you can see. we got Wilson.
Wilson.
Yeah. So
what's the deal? Why are we?
So why did we move format? Do you wanna talk about why did we change format?
I'm asking you.
Well,
as the host of the show, I guess.
Well, I think there was. I kind of feel like it's. We haven't talked about this. I kind of feel like there was two kind of main driver. We always. I mean, this show was created with the help of Power Video with Nadav and Shaul, which was a key kind of. Thank you, Nadav and Shaul. They were key in kind of creating this momentum, and they were great partners in this thing. And they kind of helped us kind of shape this and make sure that we have the right vibe. And as we move forward, we felt like they both sides kind of felt like we can take this from here. We want to reduce the.
We started walking ourselves.
Yeah. Yes. We also want to.
Why are you looking to the side?
Yeah. No, that's a good question. I have no reason to look like this. I have to. Maybe there's another camera here. I'm waiting for the other camera.
Oh, I see. Yeah. You're used to having.
Yeah. So and then we wanted to cut production costs. Production cost was heavy. We wanted to find an easier solution. But to be honest, that wasn't even the driver. I think that the driver is to basically create a platform that people can join in, and it will be more equal. Kind of the setup will be more equal. We didn't want to lose kind of the kind of the nice, warm, fuzzy experience that we have before. And I have to tell you, I kind of like the setup. I have I can do really crazy stuff. I can do like
the Winglang dictator.
Yeah,
interesting.
Why am I a dictator? They were saying, right? I mean, because I can just get you out of it very easy. They can still hear you, but and then you're back. It's very easy. So I can do all those things.
Is this GPT powered?
This is human. It requires human. Still requires human. So it's a new setup, and it's going to be interesting. And let's hope it's going to go well.
Check it out. Like everything, we're experimenting, I guess, like the alpha version of this new format.
Right. So kind of, and there's a nice effect I can do like this, and then this is a nice effect that we have. But we're not here to kind of joke around. We're here to talk about. Let's start with. Oh, nice. We got Hassan. Let's start with our first discussion. It's kind of sad, right? We're saying goodbye to a dear friend, and we're saying goodbye to the snake case. Do you want to talk about this?
Can you put some music?
Yeah.
So we actually decided. We decided. As we were approaching the beta version of Wing, which is the version that we expect people to be able to actually use and build stuff with, you need to make hard decisions. And one of the things that we've been contemplating for a while was the naming convention for the Wing SDK, and which will obviously have impact on the ecosystem and the naming convention of the ecosystem. And personally, I really wanted us to like have this like snake case style, which is coming from my personal, I guess, origins in like C programming and systems programming and Python and we're using Rust to build the compiler for Wing, and which is also using snake casing. So it has this like more of like this solid systems programming aura to it. But Wing eventually is a JavaScript family language. It compiles to JavaScript. And interops with the JavaScript ecosystem, with the JSII ecosystems, and all of those and with the web, with JSON and most of those ecosystems use camel case. And so with a heavy heart, after a lot of pressure, I was kind of like the last man standing. I went around and asked everyone, and eventually realized I'm like the only one who really wants this snake case to stay around. And I realized it's probably just me being, I don't know.
Were you the only one?
There were a few more people that kind of mourned it a little bit, but yeah, I think it's the right choice. I do think it's the right choice. I feel like it reduces friction, it reduces barrier to entry. I feel like there wasn't really clear value in like staying with this snake case, and as we were starting to use Wing and build stuff with Wing, we were like constantly finding ourselves having to like, wait, is this converting the case back and forth? And there were some bugs related to this case conversion thing, and as I was basically, I think like the thing that actually triggered the whole thing was me trying to fix one of those bugs, and I'm like, fuck it, I'm just gonna delete the whole thing.
Yeah, I was certainly going to head yourself in the morning after you change it. It's a big change, but I was certain that you actually don't. I think you're fine with this change. I know you liked it, and
I'm fine with this change.
Yeah, and I think it's gonna help our developers to adopt the language much more easier. Yeah. So
hey, it's Mark the DJ.
Yeah, Mark the DJ. He's gonna have a guest appearances today.
Oh, cool.
But
in the new format.
In the new format. I mean, he's gonna challenge the new format, to be honest. So this was about
just put the music so that we know that it's the end of the.
Okay,
no?
so you want to put the music again?
Just a little bit.
Just a little bit. So goodbye, snake case. Nice. So, and now, without further ado, we're gonna talk with Romain here. You know Romain from AWS. You want to talk a little bit about before we're gonna introduce?
Yeah, I know Romain for probably 7 years now. He was the first, or you know what? Let's bring him up, and I think he probably remembers better. Hello.
Hello.
Thanks for joining, Romain.
Yeah, no worries. Thanks for having me.
So
I don't know, 6 or 7 years, that feels both too long and also too short to be accurate. So
crazy, huh?
Yeah.
7 years? Oh my God.
7 years. So were you like the first or second?
I guess second. I think Rico joined before me. I was delayed for some like HR shenanigans. So
yeah, the third engineer to join the CDK team, and I it was really fun to like. It was just the beginning of the project. We were like just hacking on like the initial versions of the project, and so yeah, tell us about yourself. Like, who are you? Where are you from?
I guess, who am I? I'm a French software engineer. I've done all of my career so far, which is about 15 years at Amazon. Although I've been in various different places of Amazon. I kind of started in a weird spot doing sales and operations planning, kind of like, figuring out what goes in and out of warehouses to make sure we have enough space to store the stuff that we are selling.
Wow.
And planning all of that and all of these things like that. And then I kind of moved to something very different, which was product detail page localization. So I usually explain to people that localization is kind of like a superset of translation, is like translation being language to language, localization is culture to culture. And so like was semi-automated for European marketplaces. And then it kind of like expanded to like also US and China. And then I think like I did that for about 3 years, and then I kind of got bored with it and just felt like I had been around the block. And then I moved and I did business intelligence for Amazon Logistics. It was basically just figuring out information out of all the data that is produced when a package moves around in Amazon's delivery network, kind of trying to figure out when problems occur before customers do and stuff like that. Kind of did some like very scratch stuff there, and like, kind of my first venture into big data. I was like actually really big data. If you just think about the amount of packages that, Amazon holds every year, and it's just like, there's literally hundreds of data entries generated for each of these packages in their lifetimes. And so like, and then obviously customers end up being like, we want real-time insight into what's going on. And we're just like, I have no idea how this is to be
customers. How dare they?
Yeah, right. Like ask for the impossible. Sheesh. Yeah, and then I guess parts of that got me into getting into infrastructure as I was like re-architecting the monolith into microservices, and then I got involved with some arcane CloudFormation stuff, which is the point where I started complaining on email lists, and that's how Elad and I connected in the first place.
Well, how surprising that the Frenchman connected with his next job by complaining.
Exactly. I mean, like, point of pride, national sports,
Okay, so what have you been working on in the CDK?
I mean, like, in the very early days of the CDK, I still remember like that first offsite we had in Tel Aviv where like, I basically wrote the very first construct, I think, like was the DynamoDB table one.
Nice.
That was really fun. I kind of like, pivoted from construct API definitions and into like kind of even lower level shenanigans, where I basically kind of rewrote the JSII compiler over a weekend so that it could support, incremental support, incremental builds, which previously was possible. And since then, I am basically like the JSII overlord in a sense. So like, been introducing more languages and stuff like that. Kind of recently been shifting my focus a bit more towards construct libraries since then, where like this year we're kind of trying to work on a product to help people with CloudFormation template move to CDK. And so basically, like you might have heard about Noctilucent, which was written by one of Amazon's PEs, which is basically kind of like a Rust tool that takes a CloudFormation template and outputs a TypeScript CDK app. And so
really?
I've been being a pack of folks to try and basically bring this to the next level and like productize it actually, and bring additional output languages to it. It's been super fun.
Well, Romain, sorry, for people who won't kind of doesn't know JSII, can you kind of high level what's JSII for, and why is it needed in the CDK maybe?
Yeah, so like JSII is basically the technology that enables CDK to be written exactly once in TypeScript, but then used by customers in their language of choice. Caveats applying, because we don't support like every possible language. We currently support basically JavaScript comes for free, right? Because this is TypeScript. Right. But then JSII brings you Java, Python, .NET languages. So like, C#, VB, .NET and all of that stuff. We kind of recently, I mean, it's not so recent anymore, but like our latest edition is Go. And so like, it kind of was born with CDK as a solution to a problem that AWS kind of got very familiar with, which is like we want to support customers in the programming languages they want to build on, right? We don't want to force them to go to a particular language and actually have to bite the learning curve of that. But then we also very quickly became obvious that we cannot possibly afford to write a CDK for Java and another CDK for .NET and another CDK for Go. Like we wanted to have a consistent experience with a coherent feature set and API across all the languages. And we wanted to be able to write this only once, right? And so like JSII kind of became this thing. Then, why did we pick TypeScript as a starting point language? Out of, all the possible languages we had, parts of the reasons ended up being like, well, JavaScript is pretty pervasive nowadays, right? And every device that connects to internet has a form of a JavaScript interpreter on it. Like even the shittiest feature phone that has a web browser basically can run some JavaScript.
Feature phone, that's a very common thing at this point.
Yeah, right. And so like basically that was this kind of thing where it was like, okay, so JavaScript runtimes are readily available. So like we should be able to actually just be able to run JavaScript on almost any platform our customers might want to use CDK on. And so like it was a good choice. And then TypeScript, very modern, feature-full language, very expressive API. And the compiler basically had a very good API that allowed us to reason on the AST and actually type checked or type annotated AST so that we could actually extract the necessary information to be able to code generate bindings in other languages that try to be as idiomatic as possible. But then we still operate under a certain amount of constraints that make it not always possible to be exactly as idiomatic as we would like to.
Interesting. I feel it's interesting, like you mentioned, that it's basically a problem that AWS has been pretty familiar with, because eventually JSII is very similar to the SDK in a way. Like the way JSII works is very similar to how the AWS SDK works, which is basically there's a spec of the API, and we're generating classes that represent the API based on the spec.
Yep.
Okay.
And even the way it works behind the scenes is that in JSII there's like this Node.js process that runs as a child process of your actual application.
Yeah.
And then every time you interact with this proxy class, it calls the Node.js process, which is very similar to how these proxy classes interact with the service, right, in the backend.
It's basically, the interaction protocol is a little more lightweight than like a full HTTP, but to a large extent, it's very similar. I guess to like the main difference, right? It essentially we're generating an SDK based on some model, and like for traditional SDKs and tools, the actual behavior runs on the server, whereas with JSII, the behavior actually runs locally on your computer. But like that's mostly a technicality at this point. Like it could as well be a web service, and it would probably work the same.
You have a question from the audience, which I think you answered.
Did CDK or JSII come first? Did the chicken or the egg exist first? That's a very good question. Actually, I feel like Elad, you might actually know this better than me, because when I joined CDK, basically both existed. Although I guess I'm going to venture saying like technically JSII existed before CDK in the current form existed, right? We had kind of like a prototype in a sense.
So I'll answer. I think I have a pretty good answer. They both came together because they didn't approve the funding for the CDK project because they said we're not going to be able to ship it only for one language. And so we went back and we said, okay, we need to find a solution to this, because otherwise they're not going to approve the project, because it's a huge investment to build all these APIs, and we're not going to be able to like afford building all these APIs to all the languages. So it was basically a problem-solving exercise. It's like, okay, so we need to figure out a solution. So they literally came together, right? Like they literally, which is great. I like technology that comes from actual problems.
Right. Yeah. It's best to solve the problems you have than the problems you don't. Besides CDK, which other projects use JSII? That's a good question, actually. I would say that today there's not a huge lot of non-CDK customers. That being said, so I'm assuming here CDK actually means CDK and CDKs and CDK for Terraform. And so all of them kind of being CDK in the broad category. And so there's a couple of other use cases that are actually kind of tangentially related to CDK or AWS CDK, right? There's I don't remember the name, sadly, but there was there's this library that I wish I remembered his name, but anyway, he wrote a library to facilitate dealing with IAM policies and kind of all the constants that all the strings you need to know by heart when you write IAM policies.
I am Floyd or something?
Yeah, I am Floyd. That's the one, right? So technically not a CDK project, but actually has a lot of applicability around CDK too, right. And kind of ends up being pairs very well with CDK. I'm going to venture saying so. It's kind of a similar sphere.
I mean, there's another one that I know of, which is Wing.
Right. Does Wing use JSII directly, or?
So Wing is interesting in a way, because Wing uses JSII to import CDK libraries into the language, and so it basically leveraged the JSII metadata in order to reflect on the libraries that you import.
Yeah,
and the idea is that when you publish a Wing library, and that's something that we don't support yet, but the idea is that when you will publish a Wing library, it will also publish JSII manifests for it, and so you could use the JSII toolchain to basically publish this library to all the JSII supported programming languages. So in a way, Wing is basically the second source language for JSII, which is, I'm very excited about it, because I've always wanted another source language for JSII.
It's definitely been the whole adding new source languages has been one thing that I've been investigating a bit, but I'm actually approaching this from a slightly different angle, where I'm I actually want to have another source language that does not compile to JavaScript, right? Added challenge, right? Because then the whole stuff is how do we manage to get in a place where we perhaps don't need a JavaScript runtime, or perhaps get to be able to be a little bit more runtime agnostic, and gain some flexibility on that front as well.
Yeah. Yes, because the runtime part, that's a barrier for the use case, right? I mean,
so it's definitely, so there's two things here, right? The one first thing is, and that's a piece of feedback that we receive a lot, right, is that right now JSII runtimes requires that you have Node available in your path. You can use Dino if you want to, but at the end of the day, you still end up having to manage that runtime, and that's for many shops, that's not a big deal, but there's a bunch of shops where they're just but I can't, literally I'm prohibited from installing Node. And so then how do I go? And so that's parts of why, I've been trying to look for alternate core engines that we could use, so that we could effectively just remove that entirely. Because the whole stuff, right, is we could possibly bundle Node and just be you don't have to know about it, we'll just manage it for you. But then that's not going to help those people who are just but some security compliance thing means I can't use Node, right? And we don't want to trigger all kinds of red lights anywhere. So that's definitely been one of the things. And then kind of the second thing here is, and I guess probably worth mentioning, is that JSII currently is suitable for short-lived processes only, because right now anything that's exchanged between the language boundary is effectively leaked forever. right? And
Okay.
the reason why that is so is because effectively, like if usually I kind of explain this with like a Java host application and like, you know, the JavaScript sidekick. Both of these runtimes are garbage collection managed memory models.
Right.
But the semantics of the garbage collectors on each side differ slightly. And so like being able to coordinating, you know, collectability of values across two different processes that have similar but not exactly identical garbage collector semantics is actually fairly hard. And on top of it, to make things like a little spicier, we also have this problem that typically the JavaScript application, like the JavaScript core, is where most of the real data is going to live. Like Java is typically going to mostly have a bunch of like very tiny proxies to values that actually exist in JavaScript. And effectively what that means is the heap on the JavaScript side, feels much faster than the heap on the Java side, right? And I made a hackathon POC of actually fixing that problem. And then I ended up in a situation where like the JavaScript heap was full long before the Java VM actually had run even one collection cycle.
Oh, I see. They're not synchronized.
Yeah, basically because the fill rates like are just too different. And so like I ended up being like needing to force the Java VM to actually execute garbage collection, but this like incurs a GC pause when you do it. So like you don't want to do it too often. And then no, this means I don't only need to like, you know, synchronize collectability of values. I also need to somehow be able to signal like how full is the heap on both sides to the other side so that they can decide if they should try to force a garbage collector run or not. And so like this has performance implications. Pretty steep.
Yeah, I used to say we sold ourselves to the devil, basically. Like, because it is, in a sense, it's a holy grail, right? Like being able to actually write a library in one language and use it across multiple languages is something that it's a very desirable, you know, thing. And I think the cost is like we basically traded off this.
I actually talked to one of Amazon's PEs. You probably know him, like Jonathan Henson, about that, and he's basically ended up telling me like any big enough company on this earth has tried to do this already at least one time, possibly up to 6 times, and has failed every one of them.
Yeah, no, I think the only kind of viable solution is native libraries, right? Like that's basically the only common runtime that ever sustained. Yeah, it's a really interesting project. I feel like it's shepherded in the past 5 years or so, right? Like you've been through a lot of many iterations, and I feel like it's also a really interesting area of the CDK, which is kind of like hidden almost in the back. Like it's not very visible. Most people don't even know.
It's the definition of platform engineering.
Yeah,
nice.
It's the whole. If it works properly, then it's barely noticeable.
Right.
Yeah.
Right.
And to be honest, to me, it's always magical that it even works. Like every time someone had posted an issue with like Java code to the CDK project, I was like, this JSII thing is actually working. This guy's actually using Java or Python or Go. Go was actually an interesting project, right? Like that was Eyal is.
Go's definitely been interesting. I think honestly, we should have done it earlier, just because all the languages we did before Go effectively ended up being fairly similar to one another, and like Go ended up being the alien in the pack. It just looked like none of the other languages. And actually, I think the ergonomics of Go today probably suffer from decisions we have made before we knew about the kind of problems that we would run into for Go. And we might possibly have ended up in a better situation if we had done Go earlier, or maybe not. Like, I don't know, you know.
Do you think that the bindings for Go are not idiomatic?
There's pointers everywhere, right? Everything is a pointer in our Go library, and to a large extent, that does not feel very idiomatic. we've gone as idiomatic as we can, but some interesting patterns, right? Is that if you design, like, the CDK is essentially a class library, right? And so like that statement alone makes it that you can't go full idiomatic in Go, because Go is not an object-oriented programming language. Go does not have a concept of class, right? To begin with. So any flow that involves any form of like inheritance is going to be extremely awkward in Go to implement, because that's actually not like how things work in Go. And then we have this old kind of stuff where like we take idioms in JavaScript, for example. So like, property bags, and technically turning a parameter from required to optional is not a breaking change, right? Because every existing use provides that parameter. So if it's no optional, everything is fine. Except in Go, required something and optional something are two different types, right? And so if you make a parameter optional, then suddenly you go from this thing is some instance of a struct to no, this is a pointer to some instance of a struct. And effectively, that's why we ended up having to make everything a pointer, because we needed to be able to maintain that thing where like you can actually turn a required parameter to optional, and that's not going to be a breaking change. But the cost of this decision is actually pretty significant, right? Because now that means if you're going to provide literal strings, which you actually do quite a lot, right? Like the construct ID is a string, you have to get a pointer to it. But Go does not allow you to get a pointer to a literal value. Like you kind of have to run it through a variable first, right? So it's addressable. And so effectively what that means is the code ends up being literate with like JSII.string, some string literal, or JSII.number, some number literal. And like, you get used to it, but it's boilerplates that, would have been nice if we could have avoided it. And it's also kind of very difficult to, justify that to a Go shop, right? That place where you only write Go is going to look at this and be like, but why are there pointers everywhere? And then you're going to be like, well, it's JavaScript. And we're like, why do I care, right? And so it's kind of like the whole thing where we end up having to make a balancing act between we want to be as idiomatic as possible, but also like our underlying authority is JavaScript. And so like the JavaScript semantics end up perspiring left and right.
Yeah. So Omar, this is kind of a question I had. What happened to Ruby? You didn't mention it throughout the talk.
What happened to what, sorry?
Ruby. Does it?
Oh, Ruby. Good question. It started and then it kind of like got stale for a long while as we were busy working on other stuff. And then we ended up taking the decision not to revive it because there was not a clear enough signal that customers were actually asking for that. And also the Ruby stuff we had was very early stage, and there would have technically if we were to redo it from scratch today, like what was there then wouldn't take us much further. So it was a small sacrifice. It could come back in the future though. But no, there's this thing where we've kind of learned an interesting lesson with Go, because Go was our #1 requested language, but is actually very slow to pick up usage. And no, the big question is it slow because, there's actually not so big of a customer base for it today? Or is it slow because like the customers who would have wanted to use Go actually used something else because Go was not there? But then, if you have an app that's in prod today, you probably don't want to rewrite it in Go just so that it's Go, right? Or maybe you're going to do this over a length of time. But it's also possible that the whole stuff is like the signal we got is actually indicative of, some amount of zealotness in the community, perhaps. And so like effectively that could mean that you can't necessarily rank language requests just based on how many +1s you got there and stuff like that. So no, before we're going to be introducing a new language, we actually need to have a very clear customer signal that there's people who are like actually not using CDK today because that language is not there. and they will not look into CDK until that language is there. And so like if there's enough of them, like obviously all of this is subject to like, reconsideration. It's like there's no hard and fast, and like ultimately we're doing what's best for the customers and in the long-term interest. Any new language we add to JSII is effectively additional maintenance cost too, right? Because if we add a new feature to JSII now, we'd actually need to add it for all the supported languages. And that's also a non-trivial effort, right? And so we also need to be conservative with that and just try to make sure that if we're going to be increasing our maintenance burden, then we do it for the good reasons, right? And we actually, like, our community gets a return over that investment.
Yeah, and it's also another language you have to learn. I think Romain is probably the programmer that knows the most amount of programming, knows the most amount.
Yeah, I actually enjoy learning new programming languages. It's like one of the things I typically tend to learn a new language a year-ish, just because for fun and profits, right? Because I actually ended up finding that learning new programming languages, especially like the languages that end up being very different from the ones you've done before, is actually going to teach you to think about problems in a different way. And you're actually going to learn idioms that actually transpose into other languages too, and actually come to be more effective solutions to a certain class of problems and stuff like that. So like that's definitely a thing I do. No, like with JSII, it's like I don't stop at casual practitioner kind of level of understanding of these languages, because now I actually have to understand the semantics of various kind of things, and be able to know how do I represent the concept of an interface, for example, and what does that mean, and optionality and memory models and the reflection and all of that stuff. So I definitely get into a lot more, sometimes more depth than I would like to actually.
Yeah, Romain is one of those people who will always find the edge cases first and then the main cases. So he was always the person that we go to.
The edge case is the interesting case.
Miss anything?
Not edge case is the boring case.
Wait, any other questions? Anything?
I have tons of more questions, but we were 40 minutes in at this point.
It's an interesting topic. I think it's, and there's also I also had a lot of kind of maintainer, kind of open source questions, but we probably have to do this again sometimes.
We should come
whenever.
So first of all, thank you very much for joining us and giving us this talk. This was enlightening. Thank you very much.
My pleasure.
And the next thing on our
Romain, we really appreciate it. It's great to see you. I miss you.
I miss you too.
And see you soon.
Yeah. Bye.
Bye. Wow, great conversation. Very interesting stuff.
Yeah, I feel like it's really interesting to kind of be a maintainer of something that's at the bottom of the stack, right? It's a very different mindset as the CDK and the construct library, and the higher you go with the stack, the more you're exposed to the users, and but the lower you go is more about the trust that's created, right? That the system creates, and he's been doing an amazing job.
Yeah, the comment he made about platform engineering, the fact it's
if you don't notice it, means that you did a good job.
Yeah, awesome. So from one maintainer to another DJ, we're gonna have Mark the DJ right now, but unfortunately Mark needs to get a better mic and couldn't think of something to say today. So instead of talking, he sent us a picture of his cat. So this is a picture of his cat. I probably had to do better timing, but with the cat and the sound coming in the same time. But that's a special sound effect that Mark loves. Anyway, here's his song for today, The Disorder by The Features. 1 second. So I'll do this again. The Disorder by The Feature.
I'm having trouble standing still. And when I do, my mind starts to reel. Is this the way that I should feel? Is this the way that I should feel? Is there a need to be concerned? Have they done?
So we're back, and then thank you for Shiri for interrupting us. No, I'm kidding. And to our next topic, there's going to be some. The next couple of topics are kind of short, and hopefully kind of we're going to be able to go through it really quickly. And the first one is introducing a new syntax for test statements. Do you want to talk about this a little bit?
Yeah, sure.
Or do you want me to show it first?
Show it first.
Okay, so let's do this.
Oh my God, it's very small.
So it's going here. Okay, you can look. You can look here. By the way, it's still small. Okay, yeah. Let's do this. Get this out of our hair. And this.
Yeah, and
so
on the console also increase.
I'm gonna take this out. Okay, great. And why am I in the console? I should be here toggling. Oh no, a mistake. Sorry. I want to toggle
dark
mode. Yeah, awesome, great. So what we have here on the screen, we have VS Code running our extension. On the right, we have our console, basically the simulator. And the new syntax is this one. This is my new test name. I'm going to save this. Once I save this, we have this specific test here. Basically what it does, I'm instantiating in pre-flight, I'm instantiating a new cloud bucket. And then I'm running the pre-flight API for adding an object that happens during deployment, basically. And simple file text equals hello. We can go through this bucket and actually see that this file text exists with the word hello here, as you can see. And then the test itself, this is the new syntax. So we used to have kind of the new cloud function as syntax, and now this is a syntax that runs the test. And I'm going to run it from here. I can actually run it from this handler. I can just go to this handler and invoke this to make sure that it works. You can also change the test for a second and to fail and run it again. And now, as you can see, it failed. And I can also run this with the wing test app.w command that runs the test. So and it's going to work, as you can see, the test passes. But I can also run this on the cloud. If I'm going to do a wing test and target tf.aws, that's going to also be able to
deploy it and run it on the
yeah, it's going to take some time. We can run it as we do this and hope that it's going to work. I haven't tested it. Let me see. No, let's see. But do you want to talk a little bit about that syntax?
Yeah, there's a
go here.
There's a note here from Hack and Soul that I like. Yeah, so we debated whether that's the right thing to do or not, and I think it's really interesting. I think like having first class support for testing in the language, to me it feels like all modern programming languages should have first class support for testing. Now, I have never used, I've never developed anything that didn't need testing, right? Like it's the bread and butter of like building quality software. And most programming languages have frameworks for testing, like Jest and Vitess and JavaScript and JUnit, and like there's always, there's always like a very prevalent, like like one that's very popular, and like obviously in the JavaScript ecosystem, every 4 weeks there is someone that's very popular. But I think there's a lot of value when there's such things to like bake them into the language, bake them into the tool chain, bake them into the console that we have. You haven't shown that, but basically every test here in the console has like, you have like a test pane and you can run all of them. And in Wing, we also have the support for like running each test in isolation. And so it really creates all the environment for each test, and it does that for the cloud. It does that locally. So it's an end-to-end story, right? Like it's integrating the language, the compiler, the deployment, the development tools, which is why I think it needs to be baked into the language, and it needs to be baked into this tool chain. And so because it's baked into the tool chain, I feel it makes total sense that it's also baked into the language, right? Like there's a keyword for it, and it really helps, I feel, create some standards in the ecosystem, right? Like we're creating an ecosystem, and to me it's always about kind of like realizing, like thinking, what are the foundations of the ecosystem, what are the things that we want to put at the bottom of this ecosystem, so that the stuff that grows above it is healthy. And I know that you agree that testing is like
Yeah, I come from a test-driven development background. That's my best. I mean, that's how I like to write my code, and I think that I think in a way, I think there's problems with tests. I think the tests, a lot of time tests, especially when you're doing backend stuff with that requires a lot of mocking. There's a lot of what's also called as test-induced damage. There's damage from tests to the actual design because there's a lot of mocking going around, and the test basically you can't really understand what you're testing in a way. And I think that the fact that we can be able to test the bucket and the API gateway without mocking them, and then running the same tests on the cloud, I think that's awesome. And I haven't got used to this syntax, to be honest. I need to play with it, but
yeah, I think one thing that we talked about that we might change is that it needs to be an in-flight. There needs to be some kind of an in-flight modifier here, because the code that runs inside the test is basically in-flight code.
Right.
So I think that what we will do eventually is going to be like an in-flight test, right? Like we have
like
in-flight, an in-flight modifier at the beginning.
Got it. Interesting.
Which basically, same as we have for classes, same as we have for functions. And so we'll have in-flight tests, and we'll also have pre-flight tests, so you can test stuff in the pre-flight stage. You can make assertions about your infrastructure, right? Like not just interactions.
Right. Makes sense. Made a lot of sense. So this is the in-flight the tests, and we're moving into cloud services. That's our next topic. We're going to do this very shortly. I think it's something interesting about cloud service. I'm going to just clean the screen here, and I'm going to save this. So the interesting about cloud service is that we've only implemented this. Okay, I saw that Yoav.
There's a request to increase the font size on the.
Awesome. This. See how this works. So So for those of you who don't know, once I'm saving, this automatically work, and I'm gonna do service. Something different about service, we've only implemented the simulator implementation for service. Why did we?
Why are you looking to the side?
I don't know. So why did we only implement?
So first of all, what is service?
Okay.
What's the deal? What's going on?
So service is very, very simple. The API is very, very simple. The constructor gets two functions, on start and on stop. Those two functions are in-flight and
in-flight closures.
In-flight closures, right? In-flight closures, you would say?
I currently say in-flight closures until we rename function.
Okay. So the in-flight closure. So let's see how this works. I do on start and in-flight.
The snake case.
You don't like it?
The camel case. Sorry.
The camel case. You don't like it? Service started. And let's save this for a second. Once I save it, on the right side we're going to see I just saved it. And as you can see, let's hide the test here. And as you can see, we have this log message here. The service has started, and it started because the console gets automatically compiling it and starting the simulator. I can have on stop and basically do the same and stop it.
Are you kidding me that you're putting on stop on the same line?
Yeah, I'm kidding you. I didn't know it wasn't allowed.
It was not allowed.
Yeah. Okay.
I'm joking. It's allowed, but
it's allowed. So as you can see, the service started and stopped. I'm gonna clear this thing and I'm gonna save again. And now you can. Oh, I haven't cleared it. Sorry, I had to do double click because I wasn't focused. And then the saving stopped because once I saved it, the first thing that happened that the simulator when he went through the stops kind of
The stop sequence.
stopping all the services, and then it restarted again. So that's what we're doing. This is kind of the simulator implementation. What we're gonna have for the kind of AWS implementation.
So I think this is actually, like it's worth pausing for a second and talking about the implications of actually having something like a cloud service in our SDK, right?
Right.
Because so far, in a sense, all of the resources we had in the SDK were serverless. There were no servers behind them technically.
Right.
I mean, there were servers behind them, but they were like belong to the serverless family of resources.
Right.
And services actually belongs, to in a sense, a machine, right, is a service, right? And a Kubernetes cluster runs services, and Fargate clusters can run services. And so this is basically a long-running compute resource. And I think it's really interesting because one of the things that we're doing with Wing is we're trying to kind of like change the conversation between serverless and Kubernetes and functions versus, right? Like I feel like we're elevating the discussion to talk about the attributes of the compute, right? And so when you're using a cloud function, you're basically saying this is something that handles a request, right? Like it handles some event,
right?
And once it's finished,
right,
the handler stops, and memory is deleted, and there's an isolation boundary,
right?
And a service is basically a long-running thing. Like if you want to listen to a port, if you want to poll something right? Like if you want to do something that's basically a long-running activity, then you use something like a service, and then the API makes sense because it's basically on start and on stop. The system is deployed and the system is going down. These are the two entry points. And eventually when we compile it to AWS, it's going to be, I think we're going to use Fargate. I think that's going to be our go-to.
Right.
But like with everything, it's a pluggable backend.
Right.
So technically you should be able to like say, I want to deploy this service on Kubernetes.
Right.
Right. I have a Kubernetes cluster. This service is going to be deployed on Kubernetes. So I think like it's going to open up like a million possibilities, which I'm very excited about because I think like it expands the horizon for what you can do with Wing and which types of systems you can build with Wing. And to your question, your original question, why did we build it only for the simulator? Obviously, this is just a first step. And the reason we built it for the simulator is because when we were doing these dogfooding exercises with Wing, we needed to simulate local services. That was a very common problem, right? Like for example, we wanted to start ngrok in order to be able to connect the system from the outside. And so, or we wanted to start a Redis cluster locally, or we wanted to start and basically a service is the most primitive building block, right? Like everything is a service. Even Lambda is eventually a service, right? And so we realized it's a huge enabler for using Wing to be able to actually create local to start and stop something when your simulator is starting, right? Like that's the use case that this is addressing right now. Does that make sense?
It makes sense. I mean, but the stop doesn't happen. The start doesn't happen on any deployment, right? Or is it? It happens on any deployment. Okay,
of course,
great,
of course.
So
I think the API is going to be this resource is going to have a pretty rich API eventually. I think there's going to be some draining API.
Okay.
In most cases, these services have some support for draining. It's
right.
like get ready to be stopped, right?
Right.
There's going to be some API related to connectivity, right? Like I want to connect an API to this. I want to open a port,
right?
There's going to be some APIs related to auto scaling, right? Minimum, maximum amount of instances. So all of that stuff is going to be hidden, or not hidden, but is going to be exposed as part of this service resource.
Right.
There's an optional auto start, right? Like there's also an optional auto start option, which is cool. Like you can actually say auto start false. You can play with that.
Oh, and then it doesn't. Oh, nice, interesting. It goes here, right? Auto.
Share your screen now.
Auto. Oh, sorry. Are you doing this or am I?
Here, there you go.
So auto start false. Yep. And
now it just stopped.
Now it just stopped and didn't start. Awesome. And then I need to start this probably by doing in an in-flight, right?
In an in-flight.
New cloud function.
Test. You can do test.
I'm going to flight. And I'm going to do service start. Interesting.
So cool.
As start the service. Wait. I'm going to go to start the service function. I'm going to invoke it. And the service started. Let's clean this for a second. See this again. Sorry. Oh, it's already started. Interesting. So now it stopped because I saved. I'm going to clean this for a second, and then I'm going to do this. Service started. If I do it again, it won't restart. That's awesome. That's great. Nice. So
One more thing that's related to this, and this is related to the fact that it's only implemented in the simulator, is that we added support for checking if you're running in the simulator. Because otherwise, if you want to deploy this to AWS, it's not supported. If you want to go to any cloud provider, it's not supported. So we basically added support for accessing environment variables from Wing. And there's an well-known environment variable. We might add some sugar for that, of course, called Wing_target. And so you can also demo that if you want.
What I need to bring is it
bring
util?
Yeah.
Bring util like this.
Mm-hmm.
And then I do if util
end.
What do you know? What's the
Wing_target?
Wing_target, and then I need to do equal sim. I'm going to do this, and I'm going to take those two things. I'm going to just push this one here so we want to see it. I'm going to save. We should be seeing the stop service, but not the start service. So I'm going to save.
We'll see all of them.
Oh, sorry, not equal to sim. Sorry. Now we're not seeing the start service and we're seeing the stop service. So this is basically compiles different. I mean, it runs the pre-flight code.
Yeah, which is really cool, right?
Yeah.
Like because pre-flight is in a sense part of the compiler, right? So it's in a sense we were thinking maybe we should add some kind of like pre-compiler macro something, and then we realized, well, our pre-flight is basically a pre-compiler macro.
And this is huge because this is an enabler to basically define different behaviors.
Different behavior to different targets.
So I can now create a resource, a DynamoDB table resource, and I can implement the localhost implementation anywhere I want. The Kinesis instance, any resource I want. Awesome. That's great. We don't have a lot of time. That's kind of classic for the show. So we're not going to be able to do resource compatibility and learn. I'm just going to go to Cloud website. I'm going to do really.
Maybe I would jump over to the compatibility.
To compatibility,
and then we can do the website and learn next time.
I don't know. I don't mind. Okay, let's do compatibility. So what's the compatibility metrics?
So one of the.
Let me stop this and while you're sharing. Okay.
Sorry.
Yeah. Go ahead.
So basically, the compatibility matrix is a piece of documentation that we publish in the Wing documentation that shows the coverage of all the resources, all the APIs across all the targets. And if you open it now, it's going to be pretty red. Let's see.
Yep, let's get this thing out of our way. We're doing this thing right now. Let's remove this. So we're going to references, and we have next to the language, next to the API reference, we have the compatibility matrix. And this thing here, let's do this. See, no, that's not better. So this, and now we have the resource name on the left side. Oh, this is not what I want to do. The resource name on the left side. We have the actual API call. For the example, we're using get. And then we can see that get is supported on simulator, on TF-AWS, on TF-Azure, and it is not supported on GCP, and it is supported on the AWS CDK.
Yeah. And it's important to say that if there's a checkbox here, it's not only supported, but it's also tested, which is very, very important. Like we actually added, we're starting to like create test coverage that runs across all the cloud providers continuously. It's one of the tenets we have for Wing, which Eyal aptly called guaranteed to work.
Aptly?
Aptly.
Okay, I'll check it out.
And so it's I think it's one of the most important parts of the SDK is like this this guarantee that you know that this is the contract that the resource has, and it behaves exactly the same in all the cloud providers. So there's a lot of really interesting stuff that's going on behind the scene. One of the coolest things in my mind is that all of these tests are written in Wing.
Right.
And so we get this like multi-cloud testing for free through the Wing test API that you showed earlier.
Yeah. So we run. We
Can
run
you show where these tests live, just so that people have they're in the testing.
Yeah, let me try. Let's go to let's share this tab instead. I'm going to go to Winglang repo, the Wing repo, and then I'm guessing examples, I'm guessing tests, and I'm guessing SDK tests.
Correct.
Right, okay, and then we can take a look at the counter. No, let's not take a look at it. Let's take a look at the queue, for example. It's very nice, and let's look at consumer test, for example. So there's two queues here. There's a predicate because let's look at the actual test. The test at consumer does push hello, push world, and then it basically tests. There's a slip here that basically tests that the predicate test. What's predicate test? So let's see the test predicate. Okay, that that the counter itself has the value of 2. Are you able to see this? So what's going on here?
Can you enlarge the font?
Yeah, sure. If we get the consumer here, within the consumer just does c.inc. So it increments the counter. There's a distributed counter, and the test expects that within 600 times 100, how much that?
Are you asking me about math?
Yeah, I mean, yeah. Well, a minute. I'm assuming it's a minute. Within a minute, it's probably a minute. Within a minute, we should expect to see this the counter incremented by 2 because we've sent it to function. Now this test you run it very easily and quickly in localhost, and then our CI would also do this for all the targets, and eventually it will update this
matrix.
Yeah, this matrix, and we just looked at q dot at consumer, right? This thing here. So this works on those 3: SIEM, TF, AWS, and AWS CDK. Very cool. And a shout out for Tzuf.
Yes.
Yeah, that did a lot here. I mean, it's one of the perks of being a product guy here. You just need to solve me this problem, Tzuf. And she brought this great example from a UI perspective that we took from I think React somewhere. I should check this.
There's a question here that's interesting from Alon Rod, and I think that we actually talked about it earlier related to JSII. So technically, Wing classes and Wing libraries are going to be usable from any CDK language, but we really believe that writing these classes in Wing is going to be way easier and way more productive. And I think these tests are really great examples. Like you look at the test and you see like the infrastructure definitions in the pre-flight, you see the tests running and in-flight and interacting with these resources very naturally. If I had to write this test in CDK TypeScript or in CDK Java or any other solution that didn't have this pre-flight, in-flight technology, then we would basically have like to constantly cross these boundaries between the infrastructure and the runtime code. And we will show many examples. Like I feel like this is basically the main value proposition of Wing. But because we're using JSII, because we're going to be able to publish JSII libraries, then you could write these components in Wing and use them from any other language. And so there's a really interesting interop story that's related to CDK in JSII. I hope that's answering the question. What do you think, Eyal? I don't buy it.
I think I think it's an interesting question. We've been asked it's asked, the people ask us a lot about this. Why are we forcing people to learn a new language? I think we're only scratching the value proposition here. I kind of feel like the ability to kind of change your application code, refactor code, write tests, be guarded. I mean, I think that we're only scratching the surface. The concept of counters. I think that I do think that the sum is greater than all the values, and this is something we're trying to do, and yeah, I'm interested in seeing this.
Yeah, and I mean, for me, every time I build something with Wing, and we're just starting to build
Right.
stuff with Wing.
Right.
I'm shocked by the how amazing the developer experience can get.
Right.
And I feel like we kind of like neglected some of that. Our bar really got lower as the cloud evolved,
Yep.
and we've been using these serverless technologies and cloud-heavy applications
Right.
that are constantly waiting, multiple minutes to see something happening. And this is, I think, really shifting back into like creative flows, but you gotta try and use it. I feel like that's the best way to convince people.
Yeah, we're not forcing anyone. You don't have to try it.
Yeah.
So this was the show. We missed 2 topics, and we'll go back to them. Thank you very much, Romain, for joining us. Thank you very much, Elad, for being here.
Thank you, Eyal.
I think it's going to be. I mean, Mark's song, the disorder by the features was great. Let's finish with 30 seconds of the song again.
Same 30 seconds?
No, different 30 seconds. That's it, different 30 seconds. Thank you all for watching. And have fun. And let's the disorder by the feature.
What have they learned? I fear that soon I'll lose my nerve. Well, I fear that soon I'll lose my nerve. Is this disorder, what's happening to me? Well, I need some answers. The problem here is plain